Good morning. Just to be like come out in person and say exactly the same thing I've been saying in chat and nothing new. Just checking, can people hear me? Because my streaming YouTube is telling me that the video is not going out, but everything else is telling me it is. So I'll just wait till people tell me that this is actually visible at the moment. Because looking at YouTube Live, it says this video is private. So I guess I'm just not going to be able to see what's going on. I'll just trust what's happening in OBS, which is the software I use to actually put my stream together. Okay, week 4 of COMP1511. When we think about it, considering that there are 9 active weeks of lectures, we could say that we're halfway through the course, halfway through this week. I mean, really, because week 6 actually has content in it. Like, you're going to be working on an assignment. I'm still going to be going to be delivering some lectures, even if they're not like exam accessible content. They're still going to be content that I think is at least worth watching. So, and I'm still going to teach stuff. It's just not necessarily going to be like full-on content for the course. Yeah, as Tom's saying, 9 divided by 2 equals 4, computer science. Yeah, perfect. But I mean, somewhere during this week we'll hit 4.5, which would be exact. However, we do have the week 6 break and everything. Okay, people are confirming that they can hear me and they can see me, so that's good. So even if I can't see whether the stream's going, the stream is going. If anyone hasn't noticed, and it's okay if you haven't noticed because you've still got plenty of time, the first assignment has been released. It's called Freefall, and it's a kind of a homage to some of the classic arcade games of the very early 1980s or even the late 70s. If you can just, Space Invaders was, I can't remember, it was 1977 or 1979. Space Invaders was one of the very first arcade games that sort of launched the arcade revolution of that era, which was what we call the golden age of arcade games. And so it's always a pleasure to have an assignment that hits one of the kind of, I guess, what you'd call like one of the important points of computing. And it's always interesting because people always think of the important points of computing as things like winning wars or starting wars. Not necessarily computing. I don't think computing has started any wars because it's come at a time in between large scale human conflicts, and we haven't had a really big one since the 1940s. But technology most certainly has started several wars. But we also need to think sometimes about what the cultural significance is of what computing can do. And so I think that the golden age of arcade gaming, which was around 1979 to 1983-ish, was the first time that gaming as entertainment became super mainstream. I mean, nowadays we look at the gaming industry and we see it as this juggernaut of an industry that just barrels through things like Hollywood and the worldwide music industry like they're not there. In terms of the amount of money that goes through gaming, the other ones are not even significant, I think, nowadays. Whereas gaming is sort of the primary form of entertainment, which is really funny in this era of, like, Netflix and stuff like that, which is like really massive in terms of TV and film. It's still got nothing on the gaming industry. I don't know if you can see, someone's just come across to say hello. So we've got our morning chicken for today. Um, yeah, so Freefall is pretty cool. So Freefall, if you've looked at the spec already, please don't be too worried if you don't understand everything in it, because I'm going to cover a few things today that I think are very important for Freefall. In fact, it's nearly to the point where you probably don't want to even look at the spec until after today's lecture, because today's lecture um, is is going to give you the sort of overall structure for the assignment. David's asking me if Chicken scratches me. Chicken very, very rarely scratches me. Usually I have to make a mistake for her to scratch me. She's a very, very polite cat. So you had chicken sausage for breakfast. Chicken's very happy that you had chicken for breakfast. Um, she likes the fact that people like chicken. Oh, Charlotte scratched Mansfield. Um, and Chicken is totally a scaredy cat. Like Chicken, if she doesn't know people, I mean, she knows that the doorbell means new people, so usually she'll be running and hiding somewhere if the doorbell rings. I have been talking to Daniel, and we're going to do some combo stream stuff at some point. So I will probably turn up on his Friday chill stream at some time, and he will turn up on one of my streams at some time. Probably not an official lecture stream. We'll do it sometime when we're chilling out. But I'll let you know when and where that's going to happen. Chicken's called Chicken for this weird reason of just like, you know, when cats sit a certain way and they kind of look like a roast chicken. We named her after that. I don't know why we did that, but you know, totally happens. Okay, so let's get into today's lecture, because I've got a few things that I wanted to teach you about today, and they're both following on from things we did last week. So last week, I think one of our sort of focuses that we were looking into was code style and code reviews. Some of you will have done a code review already if you have a Monday tutorial. Otherwise, your tutors are going to show you a little bit. So a lot of stuff that I was talking about looking at each other's code and trying to see whether it's understandable to you or not, and also what techniques people are using and discussing the different techniques so we can learn techniques from each other. That's one of the great things about doing code reviews. I hope that everyone, while you're doing your tutorials at the moment in your labs, if you're working in small groups in your labs, please share your screen as much as you can. Well, I mean, like, don't share your personal email or anything like that, but like, if you can, try to share the screen that you're doing your code on, whether it's your VLab window or something else. It can help a lot for other people to be able to look at each other's code while it's being developed and discuss it and things. The rules that we have as a subject as USW around plagiarism and things are there to try to make sure that everyone does their own individual work, and that's really when we're assessing you on your own capabilities, which is in stuff like assignments and exams and things. But the labs, we are not assessing labs on individual work. The labs are designed so that you can learn from each other. So there is never a problem with people seeing each other's lab code. That's the kind of code we actually do want people to be showing each other. We want people to be getting feedback from each other from it. So please do that. Get active. Get back and forth about your lab code. I think that's quite important. Tom's making jokes about me and Daniel. I've never actually even spoken to Daniel. I think it's really funny that students sort of know us, and you know us because you've heard us talk for hours and hours at a time. But I think it's funny because, like, I think we're connected together in your minds because you take both our courses in the same year, sort of thing. But then a lot of the time we never meet each other, a lot of the lecturers, because I think a lot of the time, like, being a lecturer involves like just being really, really focused on your own course and not really getting that much time to do other things. But hopefully Daniel and I managed to have a chat and hang out and stuff. I'm going to Actually, that would be really, really funny if we swapped lectures and actually tried to teach them. Uh, could get messy. Um, Max is asking you about two-dimensional arrays there. Let me get to that. I have time set aside for two-dimensional arrays today. Oh, Michael's here. Hello. Michael used to be a tutor, which is why he's here as a moderator. You can act as if Michael is a tutor. He will answer questions that are, call it? He will answer the questions the same way that the other tutors answer questions. So you can take his word as with that level of authority. Riley didn't get to take maths with Mansfield. You can always just turn up to his Twitch stream anyway. Okay, let's continue. So, we looked at functions. We looked at the ability to split our code up into separate portions, and putting it in separate portions means that we're able to reuse code. And the reusing of that code means we're not typing it in again, which is quite good. It's like looping and functions are two ways that we can not have to write the same code over and over and still be able to use it. Functions are even nicer because it pushes it out somewhere so that we don't have to read all of the detail of what we're doing every time we perform a specific function. You don't get halfway through saying a word and you're like, no, that's just the name of the thing. You just said the same thing again. But it sort of makes sense, and you understand why functions are called functions, because they're there for a purpose, a function. Purpose and function, really similar words. And they're there so that we can reuse them. And then we looked at arrays as well, which is collecting identical variables together. Arrays form one of the core blocks of what we do in computer science, because an array is just a piece of memory. It is literally a big chunk of memory that stores multiple of the same thing in it. If we wanted to get down to the nitty-gritty, the way that our entire memory on our computer, like all of the RAM and all our hard drive and everything, is also basically just one large array. So you could have, 16 gigabytes of memory addressed from 0 up to n-1, and each one of those is a specific size of memory. That's actually the 64-bit, 32-bit thing. So that's how many possible indexes there are in the entire piece of memory. A little bit of funny trivia: if you look carefully at how many pieces of 32 bits a 32-bit number can index. So if you did that multiplication, I'm pretty sure it's 32 bits, you end up with exactly 2 gigabytes. And so now you know why most of our systems are 64 gigabyte systems, because with 32 bits to look at memory, you can actually only look at 2 gigabytes of your memory. So around the turn of the century, so about 20 years ago, some of you were born then, some of you might not have been, there was this movement where we had to switch from 32-bit computers to 64-bit computers, because we started having more than 2 gigabytes of RAM affordable in a computer, and so we needed a different addressing system to be able to use it all. There were some kind of stopgap measures leading up to that, but once we went to 64-bit, we're now at a point where we can address, what are we doing, 2 to 32, like trillions of gigabytes of memory instead of being limited to the 2 gigabytes of memory. So it's a good thing to do. So we looked at arrays. Today we're going to be expanding on both functions and arrays. So we're going to have a look at what libraries are. So I have mentioned libraries before, and we've been using them for a while, and so I'm going to talk about what they are. I'm not going to poke too deep into this, but I am going to show you 1 or 2 things from the C standard library as well. People asking about scanf. Oh, that's good. I'm glad you're asking about scanf, because I dropped a little present in the lecture section today, which is actually a demo of scanf and some of the stuff, how it works. I may go through that if we get time, actually. Then we're going to look at arrays and two-dimensional arrays. The two-dimensional arrays are stuff that we're going to use in the assignment as well. These are arrays inside arrays. I will talk about that more when we get to it, and I'll show you formally how that actually works. Okay, first thing we're doing. A quick recap of functions, and I have sort of said this before when I was talking about what we did last week. But the details of what a function is. So, like a variable, it has a type. The type is what the function, if you look at where a function sits in code, and you say this is an integer function, or this is a double function, that is, in a sense, if you take the piece of code where the function is called, the function will transform into a value of that type when it finishes running. And we can say that the function returns its output type. That's the output type. It also has a name. It needs a name because we're going to name the function, and we're going to be using the function by calling its name. So we very much use the word call when we use a function. So it's really hard for me to use a different word, actually. So anytime that, say, in our main function, we say the name of another function, that's us calling that function. And what happens is when we get to the call, we'll jump from our main to the other code, run the other code, and when it returns or finishes, we will go back to our main, wherever it was. That's not just the main. Like a lot of other things in C that we've seen, things can be inside other things. So we could call a function, and that function could call another function, and then they would return back through to the main. So you get this same kind of thing that we've had happening with while loops and if statements, where code can contain other code, and that means it can contain itself in a sense. We're not going to go too deep into this, but I should mention at least there's this whole other field of how to use functions called recursion, where a function can actually call itself. It's a slightly advanced technique. I'm not going to teach it in 1511 because for a lot of what we do, not everything, for a lot of what we do, we can get away with not knowing it for now. And I have other content that I think you need to know, which solves different problems rather than recursion, which solves similar problems in a different way. You will end up learning it, and you can actually teach yourself if you really want to, because there's lots of stuff online about how to do it. But in 1511, we're not going to touch on that yet. Anyway, the function itself has curly braces and a body that's called, and it uses a return keyword when it wants to finish and give back the output. Little simple demo of a function that we had. Sometimes we want to make sure that the function is known in our main, and so we would have a declaration of the function here. If we want to, we can have the whole body of the function here, but personally I prefer to have a declaration here and then the whole function somewhere below. We are going to look at the detail of what the difference is between the declaration and the definition and why they're separated later on in the course, but we probably won't be getting into that until around the time of the second assignment. First assignment, you can be pretty chill with the use of functions because we're just going to do it in this format, so all of your functions can be in this format. Declaration above the main, which is just a one-liner saying what the inputs and outputs and the name of the function is, and then you can use the function anywhere you want in your main. And then the function itself is down here. I mean, another justification of why we would split this up like this is if I have a function that uses another function, then I'd want all of the functions to say what they are up there, so that down here I can just write them in any order. Otherwise, I would have to say really specifically that one function and all its code would have to be written before another function and all of its code. So yeah, so this is the basic layout. To use the function, we're going to call its name, and then we're going to give it some input values that match the types that it wants. And then it's going to transform itself, in a sense, into the output value, which is an integer, which can then be stored, like so. So it's always going to be a bit like this, where anytime we use a function, it will be the same type as its own type. It will always require inputs of the type that it wants. Note that it doesn't have to be the same name, because it's not linked to this variable. The only thing it takes from this variable is the value, which is 4, but it doesn't actually take the variable itself. So usually, it doesn't have access to the piece of memory that it's looking at. I say usually because we are actually going to get to the point where we will be using that memory. And arrays do, because they're a slightly different case. If you give an array to a function, you will actually have access to the array itself. There's some subtlety about what's going on in there in memory, and I'll be talking about that a little bit on Thursday. And so I'm slowly kind of, it's always kind of a bit fiddly when I'm teaching about some things, because what I'll be saying to people is, this is how this works, but bear in mind that everything that I teach you, well, not everything, but a lot of the things I teach you, they're more subtle than what I'm saying. There's more stuff going on under the hood, and what I'm saying is this is as much as we need to know, and we will stop trying to deep dive for the moment until I've taught you a bunch of other concepts, and then we'll deep dive into what they are. So for example, I said int main void, don't worry about it. But now you understand that main is a function, it's an integer function, and it happens to not take any input, but specifically has this keyword void saying it doesn't take any input. Alright, so why are we using functions? One of the big things that we're going to get out of functions is we're going to not have to repeat code if we're doing the same thing multiple times. So let's say I'm running some code that is, I don't know, constantly outputting to screen a grid of possible information. Let's say stones in the game Freefall, or if you haven't yet, you can actually play Freefall in your terminal using the command 1511 arcade and then solution. If you want to, you can actually run 1511 arcade with your own code, and it'll have your code running the back end of Freefall. Obviously, probably not yet, unless someone's already completed the assignment, which is always a bit scary. But for anyone who, once you get to the certain point where your assignment is mostly working, you actually plug it into the back end and play it like it's a real-time game, which is a lot of fun. So if I had something that I wanted to print out the whole screen like that, and I wanted that thing to work, you know, let's say 60 times a second, I don't want to have to write that code again and again and again in my main function or something. I would prefer to just have a little word, which is like the function name, saying, okay, do this thing, and then have the code itself bundled away somewhere else, and I could use it multiple times without ever having to write parts of that code more than once. The other thing that does, and this is quite important, is that makes it so that we can only ever write that code once in our program, which means that if we want to modify it, we don't have to find it in multiple places and modify it. I showed you a perfect example of this when I was doing the it was the dice checker or the dice statistics, and I modified one die but I didn't modify the other, and then I wasn't sure why it wasn't working. I modified the code for the second die instead of the code for the first die. Whereas if I had a function that said, okay, read in information from a die, and I changed that function, then that would work for both of the dice. And so you can see already that's a perfect example of why we would use functions. The other thing is it makes your code really, really easy to understand. So if we get a good enough well-organized piece of code with functions, my main function is really short. So it ends up really short, and all it has is a series of functions in it saying, okay, do this, then do this, then do this, and then do this. And because you're using well-written function names that you've created yourself, you can actually read the code. So this kind of holy grail of using functions in code is a main function where someone could read that and get a decent idea about what's going on in the program, even if they have no idea how to program themselves. Because what they read is a series of English words saying, set up, I can't remember what it is in Freefall, because I haven't looked at the starter code, but it's like, set up map, then print map, then take input, then print map, or whatever, you know, things like that. And so it goes in order like that, and you can just read it line by line and go, okay, I've got a decent idea about the overall flow of this program. And we can make it really easy for ourselves like that, by pushing everything out into functions. Then all the weird complex stuff that's hard to read is in the functions, and it's really easy to just read the function names and see how things go. We'll see about that today, because I'm going to put together a piece of code today that includes functions, and we'll try to do it in that kind of clarity. Okay, I'll check a couple of questions. Oh, people asking about marks and stuff like that. Oh, Liang's saying that you tried to play it via VLab, did you? And it was too laggy. I apologize. I don't know if we have a good solution for that. Yeah. I don't know if we can download that at all. Anyway. Other things... I think Tom's answering most of the questions there. Oh, Mason, he tagged me in something. For the assignment, are we allowed to add optional features, or is that going to confuse the markers? What we do have... let me actually just check on that. I've got the assignment here. Did we have... Oh, we don't actually have... Sometimes we've done a thing where we say you can go beyond what's in the assignment, because we usually have that open where people can send us stuff that they've done with the assignment. What I would suggest, if you want to go beyond the spec and add cool stuff to the assignment, you can definitely do that, but try to submit something that just matches the stages in the assignment rather than submitting something that does stuff that's outside the behavior. I mean, chances are you could write that in such a way that you would still pass all the tests for the assignment, but I would think that you probably want to keep two versions of it. One which is exactly to spec that you can submit, and another one which you can email to us or something like that later and go, hey, check out this cool thing we did, and then we can have a conversation about it and stuff like that. Yeah, so talking to Tom about that, we do have CS1511 Challenge, which is where you can send us cool things that you're doing outside of the course. We've actually gotten a couple of emails already about the challenge exercise this week, where we gave people an option to do things which is beyond what's in the course, and if people did it, it was like, because this is outside the marking system, you can email us to talk to us about it. So we might have that... available for the assignment as well, and as we go through the time of the assignment, we might actually make changes to the spec to add in some ideas of what you could add to the assignment if you really wanted to. That's not really super important because the majority of people in the course are going to be working through the stages of the assignment and not necessarily looking for a stage 5 or 6 or anything like that. But if we get around to it, we might. It's always a matter of deciding how much effort we want to put into things, because we could put a lot of effort into like challenge exercises level for assignment 1, but at the same time we're writing assignment 2, so it's probably better that we put our effort into assignment 2 that more people are going to look at than just the extra bits on assignment 1. But we'll see how we go with that. At least if nothing else, we're not saying that you have to stop at the end of the assignment. If there's more things you want to do with it and play around with it, that's what the CS1511 challenge email address is handy for. Okay, so adding on to functions, I wanted to talk about libraries today. So we've already used the standard input-output library, and we've used that several times. But C has a bunch of what we call the C standard libraries. These are ones that will always be available to you when you're making a C program, because the compilers that we use to translate our code basically own copies of this code. So if you say standard.io.h, this one here, if I do #include standard input output.h, I have an assumption that the compiler is going to give me its version of standard input output, and most likely our compilers that we're using are going to be the most current versions, and we can trust that our printf and scanf and things like that are going to work as we expect them to. This is a level of trust. If I manage to find a compiler, because I'm sure the code is still out there, a compiler from, let's say, the early 80s or something like that, I may not have all of the functions that I think I'm expecting to have, and they may not work in the way that I expect them to. Because C is a language that's developed over time and it's been changed over time. But in general, we can expect that what we're going to be using is going to know what standard input output is, and it's going to be able to give us access to those functions. If you want to, in the weekly tests, we've given you the cheat sheet, which is under kind of strict exam conditions. That would be the only information you'd be allowed to use. So if we were doing a full-on closed book exam, that would also be the only information you'd be able to use. It actually has laid out quite nicely a set of the commonly used functions in the C standard library and what their inputs and outputs are, and a very brief description of what they do. If you want more information about these things, you can always look them up. Google has a lot of resources. The manual in Linux has a lot of resources as well. We'll look at that a little bit today, actually, once I hop over into doing code. And so there's a few things that we're going to use a lot. Standardlib.h is something we're going to use a lot. Math.h is something that you can look at, and I think is reasonably easy to understand what's going on, Math.h, because it's just doing things that maths does. So if you've already done some maths, you will understand what the purpose of Math.h is, and a lot of things in Math.h, as opposed to a lot of the things in the standard library, which is like this package of things that is used most of the time. There's a lot of stuff in there you're not going to understand yet, because they're things that you learn about the deeper you go into programming. So as I was saying, don't worry if you don't understand everything that's in there. We can still use a fair bit of this stuff without fully understanding it. For example, in week 1, before I had any idea about anyone being able to do any programming, I used printf anyway. So this is the point where I say, okay, the training wheels are off for include standard input output now. Now I'm saying it is not just it's not just a line that has to be in every program. This is now showing you that the hash include is basically going to take a chunk of code that is the file, there's actually a file, standardIO.h, and basically copy paste that into your code. So it's going to grab all of that code and copy paste it wherever the hash include command is, which is why we usually have to have it at the top, because we have to have it at the top of our code so that anything else in our code that uses functions like printf and scanf can have already seen that code. So compiling line by line from the top down, it sees the hash include before it sees any of our code, so that way it knows those functions. Very, very similarly to the way that we would declare a function at the top of our code before we write any working code, so that everywhere else in our code knows that this function exists. Me doing the hash include standardIO.h would put these kinds of lines at the top for things like scanf and printf. I don't think it necessarily does that kind of copy paste, but it's definitely grabbing that code and looking at it before it compiles your code. So, a couple of things we can do with some libraries. Here's some really simple code that happens to use multiple libraries. In general, actually, the more libraries you use, the more simple your code will be, because you'll just have these functions that you're using otherwise. So, I've included the math.h library and the standard library here, along with the standard input-output library that we use a lot. And so I've got two numbers. They're just two integers. This is just a pretty simple example. And I could change one number to its absolute value by using this function, absolute of the first number. I'm pretty sure this one's actually standard library. Math.h, if I remember correctly, and I'm saying this specifically, I'm saying if I remember correctly, because I don't bother memorizing a lot of this stuff. There's a lot of things that I consider to be just regularly available to me, which is like what's in all the libraries. I tend to memorize the things that I use a lot by accident, just by using them a lot, but I don't go out of my way to memorize these things, and I think that's okay, and I think it'll be okay if you do that as well, because through a programming career, we're going to hop between different languages, and the things that are important to us is how we translate human ideas into computer code. So how do we translate our need to do multiple things at a time into whatever looping structure is in the particular language that we're working in at a particular time, rather than trying to learn the nitty gritty specifics of every language that we use. Some people can do that, but some people have photographic memories as well. Not everyone does. So knowing what you really need to know and what you need to look up is pretty important. So I don't even bother remembering what's in everything. One vague thing that I do remember about math.h is I'm pretty sure everything in math.h is doubles. So all of these are double function types. So it's functions that work with fractions and other things, which means that the absolute value of an integer thing might actually be in the standard library. I could look it up and find out, but I won't for now. Anyway, so this is absolute value, which means that if first number is negative, -4, and I do this function, I'm just assuming this is an integer function, it will change the -4 to a 4. And then there's another one that can calculate the square root, so I'm pretty sure this one's a standard library, and this square root is the math.h. This may or may not be useful for your assignment. I'm pretty sure there's some square root going on in the assignment. If I square root that, then I can print out the final number. So for example, it's -4 gets transformed into 4 by this function, and then this function creates a new variable here. Well, we create a new variable and we assign the square root of the 4 here. So this is probably going to be 2. As you go on and get more comfortable with these things, you will find that there are things in the standard library that you can use to make life easier. So it would be really fiddly if we had to teach you the exact code that's going to print stuff to terminal and other things. So it's really nice having stuff like printf, scanf likewise. We want those things to be sort of reasonably easy to use. And a lot of this stuff gets even easier. Like when you consider absolute value, you could make your own absolute value function if you wanted to. But sometimes it's more convenient just to use one that's already made if it's already made. So now going forward, we'll be able to use libraries for different things. Right now, there's not a huge number of things that you need from libraries, and we try to keep it that way with the first assignment. I think the only library you're going to need in the first assignment is the math.h. But as we go deeper into things, we're going to start using more things from the standard library. And when I start introducing new variable types, we're not going to do that till next week, like characters, which are the letters and things, then we're going to use the libraries that go along with those to get stuff working. Just checking questions. Yeah, QWERTY's saying libraries allow us to run different types of functions. I wouldn't even say different types of functions. They're actually all specific functions. The library has a package of functions. Let me do a quick Google. Standard.io.h. I'm just Googling random stuff here. You can actually look it up in the Linux manual as well. But here's one of the places, just random places where you could find information. So here are some of the standard libraries. There's quite a few of them. I don't know if that's all of them. I think it might be all of them. Yeah. So standard input output.h has a bunch of hash defines here. We're actually going to be using this one, end of file. If you've had your tutorial already, you've seen a bit of this. End of file we can use to say that input has ended when we're putting input into a scanf. But there's some library functions here, so fclose, clear error, Let me see if I can find any that we know. Just looking for printf and scanf. There's fprintf and printf. There's different kinds, and sprintf, vfprintf, vprintf, vsprintf. So there's all these different versions of printf. I haven't shown you all those versions of printf because they all do subtly different things, but for our purposes, we were just using the basic form of printf. And here's some information about it. If I click on it here, it's probably going to tell me about it. This is the same information I could get once I go into my VLab later. I'll show you. I can type in man for something to read the manual about it. It'll have the same kind of information. But yeah, this tells you all of the different things. In fact, this shows you all the percent strings you can use. So there's the %d that we've been using. There's a %. Oh, this doesn't even show all of them. There's a %lf as well that we've been using. Yeah. And shows you some information about it. So I won't go too deep into that, but every function in the standard library has information about it somewhere that you can find. Oh, Tom's saying we won't have used end of file this week? I'm not sure. Maybe. No, Reese is saying it's used in the calculator lab exercise. Yeah, because we're reading up until input finishes. I actually have a demo in the lectures, in the lecture section that has some code that uses end of file as well. I might show you that in a second. Yeah, I'll see where I'm up to. If I hit the break slide and I think I've got time, then I'll show it to you. Otherwise, I've got other things I want to show you today about two-dimensional arrays. Okay. Oh, I think I've already spoken about what's in this slide. Basically, if we use libraries, we get more functions. And if we get more functions, that means we can do more with our C code by using code that other people have already written. Just having printf and scanf allows us to do more with like little one-line pieces of code instead of having to write out all of the printing and scanning that we might have. Yes. Okay, good. Everyone's saying that there was end of file in a bunch of stuff this week. I thought there was, and I was like, hang on, I thought Tom has already taught a tute this week. Have you? Oh no, you're not on Monday, are you, Tom? I can't remember. Yeah. So, yes. There will be stuff about scanning until the input stops. I can actually show you. Okay, let's get into it. I will spend a small amount of time on this scanf demo because it's got a bunch of code in it. Oops. I need to go to my COMP1511 folder, and I have lecture 7. Yeah, I was playing around with the scanf demo last night. Scanf demo. Okay, here's a little demo program I wrote that is a slight expansion on what we were doing with functions and showing how if a function sort of transforms itself into something else, then there's a few things we can do. And knowing that everything that is in standard io.h is just a function in the same way that we can write functions, we can use them in the same way. So for example, scanf outputs an integer. The output for scanf, I've typed in, wait, let me just, if I go cd tilde, this actually takes me to my home directory here. It replaces this with tilde, my home directory. Lecture 7, just going back to this. This means that my command prompt is shorter. I just want it shorter so that I can type in commands on one line, make it easy for you to see what I'm doing. So I do man scanf. It's going to open up the Linux programmer's manual for scanf and all the other versions of scanf. So scanf is an integer function that outputs something after it reads something in. Oh, don't worry too much about the type of this here. that's a bit confusing. We're just going to understand what I've taught you about using it, where that's the stuff in the double quotes. So scanf family of functions scans input. It's got stuff about pointers. We'll talk about pointers soon, very soon, possibly Thursday. I think definitely Thursday. I'm looking for what the output is here. Format string. If processing fails, no further scanf returns, blah, 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 blah. I swear somewhere here that'll have the output. It's being really, really formal about everything about the input so far. I'm going to skip over some things. I'm just using the up and down arrow keys here to look through this. Wow, so much detail. It still hasn't told me what the output is. I know I could look this up elsewhere and it would explain it as well. Oh, wow. Oh, return value. There we go. On success, these functions return the number of input items successfully matched and assigned. So, if I scanf with multiple things in it, it'll tell me how many things it's matched. If I scanf with just 1% D, then I'm expecting an answer of 1 if it read an integer in. But I will also get this, the value EOF, capitals EOF, it's a hash define, is returned if the end of input is reached before either the first successful conversion or a matching failure occurs. Matching failure means it's trying to read something, but it's not the type it was expecting. EOF is also returned if a read error occurs, in which case error... we won't bother exactly about what's going on with errors. But what we're getting is our return value is going to be the number of items that have been successfully read, or the EOF if the information stream has ended and we're not getting any more information. So what I can do here is scanf is going to return the number of things that successfully read. So if I want to, I can loop up to 10 times and say, okay, read 10 numbers. And then I'm going to read in, each number I read in is going to add 1 to this number count every time it runs, which means I have not actually done something along the lines of num count plus plus here, because I'm actually adding to number count here. Have I showed you? I've showed you plus equals before, right? I'm pretty sure I've showed you plus equals. Not sure if I have or not. Oh, Tom was helping me to search there, I forgot. I mean, the thing is, like, in the back of my head, I would have searched for output, and I wouldn't have found a return value, because I was, like, using the wrong keywords, so... But yeah, being able to search through the manual is pretty handy as well, as you saw, based on the amount of detail. But anyway, if this all works as I hope it will, scanf, every time it reads a number in, will actually read the number directly into the array, and then it will return a 1 for being able to read in one number, which I can add to the current value of the number count. So the plus equals is just to accumulate. I'm pretty sure I've taught you about plus equals already. So this while loop with this really, really like concise one line, if it gets the correct input, is going to count through up to 10 and put exactly 10 numbers into this array. This is a super dodgy way of doing things. I wanted to show you this just to show you what scanf can do. Scanf could, if you give it invalid input, do other things. So, but I just want to show you an example of how that works. Another way that we could use scanf is we know that scanf can match multiple patterns. So I could say, here are 10 integers, and here are the 10 elements of the array. Read all of these things in. As you can see from this, this is a really messy, slightly dodgy solution. But I could, you know, if I wanted to, do the entirety of this thing in one scanf call. And the interesting thing about these 10 numbers is that scanf is actually going to ignore any enter keys I press in between. It's not going to try to read the new line character as its input, it's not going to try to read any of the spaces either. So I could put any amount of what we call white space, invisible characters, in between these %d patterns, and it'd be okay, it'd ignore them, and it would still read those 10 numbers in. I don't suggest doing things like this, because this is really has us constrained to exactly 10 numbers. And if we were trying to read in, 50 of them or something, then we've committed ourselves to like doing this massive copy paste of all these things and setting up the numbers and stuff. It's not great code, but I did want to show you that this is possible, and this is one way that scanf can work if you really want to. Super messy though. Other things we can do, if we want to read until the input ends, I could have, this is the sentinel value that I've spoken about before, where I've got keep looping, and I have a test for keep looping here. So I'm going to keep looping as long as this thing is 1. And then I'm going to read a number into the array, and I'm going to store the result of scanf here. So I run this function and I store the result. The result is either going to be some kind of success or some kind of error or other things. But if the result happens to be EOF, end of input, and I see, I kept this in here so you can see what's going on, we can press Control D to end our input. So I can have a series of inputs, and then I press Control D, and that's going to say, okay, input's finished. It's going to send a message to scanf basically saying there's no more input. Scanf will then return this hash define EOF rather than a number, because it wasn't able to read any more characters or any more numbers from the input. It'll say end of file instead. So if it says end of file, I say we've finished input, and I can flick keep looping to 0. Next time I go around, keep looping will be 0, which is false, and so this while loop won't run anymore. So this is me using exactly the structures I've taught you with the sentinel value here, and there's actually more than one thing we can do, because if we reach 10 and we don't get the end of file, we still want to stop because we don't have any more array to fill up. Yeah, so that's a way that we could, if we want to, scan until end of file. We want to get even trickier with this. I can do this loop here, which is even trickier, where I say I can put a function inside the while loop itself, inside the question of the while loop. So the expression of the while loop is something that's going to be run before the body of the while loop runs each time. And if this expression is true, then the rest of the loop runs and it happens again. If this expression is false, the while loop doesn't run and it gets skipped over and it stops looping. So what we can do here is I can say the check that we're doing in the while loop is actually a function call. So I do the scanf. So no matter what, I will try to do the scanf, but if I get end of file in that scanf, so if Control D has been pressed in the terminal and the input is finished, it's called end of file because you can also use things to read an entire file in, and it'll actually have a kind of like, it's not actually, but it's sort of like a marker at the end saying that the file is finished. What I can do is I will read input until that, and the Control D or the end of file. And each time I do that, all I'm doing is adding 1 to the count to move my iterator along. But actually the work is happening here. So scanf is going to read a number, put it into the array. If it did that successfully, it moves on to the next number. If it didn't do that successfully and the input is finished, then it will stop. So here's a way of doing actually the same thing that we're doing in this loop, but using some of the subtleties that we can understand, that the function call itself will transform itself into the type of its output, as in an integer, and can be tested against something as it runs. So this is kind of like flowing on from the consequences of other things that we've learnt to do a while loop that is like this. So it's quite subtle. Someone's asking, is end of file -1? In our current implementation of C that we're using for this course, it's -1. but I can't give you any guarantees on that because that depends on standard input output. That's why I'm going to use the their hash define constant for it. So somewhere in standard io.h there's hash define EOF to something. I don't know what it is, but it's usually -1. That's the way I like to think about it because it's not always going to be the case. Chappa Chappa is saying, aren't you left with EOF in your array though? So the trick with EOF is the output of this function. That does not mean that the function has completed and put something into this array or not. So there are ways that scanf can run without actually putting something into the array. Let me show you. What I'm going to do is I'm going to comment out most of this code and I'll just show you the final example. Because I don't want to have to enter 10 numbers multiple times. So I've just used this commenting style to just remove a bunch of the code that I've written here. I still have the declaration of the counter and the array that I used in all of the examples. But here I've only got this one, which is going to ask me to enter 10 numbers, up to 10 numbers, and press Control D when I'm finished. So I'm going to compile this and run this and show you. It's going to have a loop here that's going to print out the contents of the array when it's done. I'll just DCC. I think I called the output file scan last time. Okay, so scan is going to enter 10 numbers for the loop. So let me just enter, say, 1, 2, 3, 4. And then I'm going to enter 5, 6, 7. So note how I'm just splitting these up however I want. Scanf is going to ignore things like new line characters and spaces and stuff like that. Let me just put a whole lot of spaces here. Have an 8. Okay, so I've entered a bunch of things. I'm going to press Control D now. Control D is going, oops. I have made a mistake somewhere. Control D was going to end my input. And I have a runtime error. Index -1 is out of bounds for integer type 10. So I'm using an illegal array index somewhere. So where did I do that? Interesting. I wonder if... Did I actually... No, this looks like... See this? Please enter 10 numbers for the loop. And I was expecting this. I think I'm running an old version of the code. And I've just given away the trick I was going to show about why that original piece of code wasn't that great. Okay, let me just... Okay, I'm going to rm scan to make sure there's no executables in here. And now I'm going to compile my scanf demo. Oh, wait. The other possible issue is I didn't save it. Looks like I did save it. Scanf demo. Oh, I think that might be it. Did I spell it wrong? No? I'm not sure what went wrong there, but we'll see. Now I will compile this, and I've created the scan file. Now I'll run it and see. I'm not sure what happened there, but I think I didn't compile properly. See if anyone else can... Maybe I didn't save. I'm not sure. Let's see. Okay, now I'm getting the right output. So I definitely wasn't running the right program before because it was running one of the early ones that just said please enter 10 numbers rather than this code that I thought I was running, which is press Control D if finished. Okay, so I had, say, 1, 2, 3, 4, 5. So I just want to show you that you can have different amounts of space here. And if I press Control D now, that will end my input. And we'll see that the numbers 1, 2, 3, 4, 5, and 6 have been inserted into this array. The rest of them remain 0 because I declared the array as being all zeros to begin with, just using these curly bracket 0 here. So this is just a little example of what we can do with scanf if we want to. Terry's asking if it scans, if we do %d 3 times, and then we put 3 numbers in, actually, let's just run it. Terry's asking about this. 1.52. What's going to happen if it does this? I'm going to do Control D here. We're going to have a look at what happens if we try to put a number with a floating point into a scanf. Oh, it did not like it. Okay. Extra subtleties of what's going on here that I'm not quite showing you right now. Index 11 out of bounds for type integer 10. What this means is I've gone off the end of this array. So there's a bit of subtlety going on here. I don't want to go too deep into this because there's a lot of thinking going on behind this, and I don't want to confuse people with it because it's not 100% necessary to know. But what scanf will do is when I put an input like this, I put 3 numbers into what we call an input buffer. It's nearly like an array. It's a chunk of memory that has all of my inputs. So I put these 3 numbers in. In reality, it's actually a series of characters that scanf is going to read and decide if it wants them or not. So if scanf reads the 1 and says that matches %d, I can take that. It reads the 1.5 and says I cannot take that, and it will return 0. And then the next time scanf runs, as in it will loop and it will try to run again, it will come back to this. So it will come back to this 1.5 and it will try to read it again. And it'll say, no, I couldn't read that 1.5. So what's going to happen in this loop here is the scanf keeps running and it says, I did not read an end of file, so I will go again. Number count keeps going up. So this code has some significant issues with it, and I might want to change this to say that scanf is going to keep going while it equals 1, for example. So anytime it doesn't read a number in, I'm going to make this thing fail. And I can even get to this point where getting rid of this. And so I can say, if scanf got numbers, it will give me a positive number value. Oh, actually, I don't want that. No, I want equals 1. Because the 0 is the only thing that would fail, then the end of file might not necessarily fail. So I'm saying here, I only want this while loop to consider itself to be successful if it read in exactly 1 number. And so if I try to read in the 1.5 and it doesn't work, it's just going to reject this loop entirely and say, okay, we are no longer continuing to take input. So if I save this and I compile this again, now my while loop is going to accept integers only. And if it doesn't find an integer at any point, it's just going to stop looping. It's going to stop taking input. So let's try this. Compile that, scan, and we'll try. Who was it? Was it Terry? It was Terry's example there of trying to give it a value that it doesn't want. So when I scan the first one, it's going to give me back a 1, saying I read 1 number in. When I scanf the second one, it's going to give me back a 0, saying I did not read a number in the format I liked. And when it hits that 0, our loop should stop. So we should only have the 1 in our array. Ugh. Haha, haha, I get what's going on here. It still read this. I think it actually read that. So it reads a 1, and then it gets a 0.5 and says, that's something I can't read. So it actually took this thing and then took the full stop afterwards as just being like, okay, there's a symbol that's not in an integer, but I can still read the rest of it. Let's do another test. 1, 2, 3, 4, 5. With that number, 0.78967. Let's see what it actually takes here. I think it's going to take this number and then reject the rest of it. And then when it tries to read this string of characters, it's going to say that's not an integer and it's going to stop. Let's press Control D and see what happens. Oops. I should have put an enter there. This is the input that I wrote, and this is the output that the program wrote. Because I didn't press enter in between, I didn't get a gap in between them. But we got 1, 2, 3, and as I guessed, it reads this part of it as an integer, and then the loop after that, it tries to read this as an integer. It fails and says, I didn't get a 1. I'm no longer going to continue, and so we won't try to do any more scanfs there. So lots of fiddly little bits that you can think about, and this all stems from the ramifications of what is a function, what does a function output, and what can it do, and what can we do with functions, because we can put them in places in our code that you may not originally have expected for functions to appear. So we can actually put functions in the question of a while loop. We can put functions in the question of an if statement as well, and other things like that. So I've left this code all uncommented. So there's lots of different ways of doing things in the lecture section. So you can play around with that, see what you want to do, modify it, and just learn from it if you want. Okay, back to what we were talking about here. I'm going to go on break now. We'll take 5 minutes break, and then I'll come back and I'll go in and talk about two-dimensional arrays. I thought you might enjoy... I'm just trying to find somewhere for my face here. You might enjoy this little GIF by a little studio called Parallel Studio. I wanted to say that we're getting to the point now where we're making code that's harder. Which means problems are going to last longer before you have a full understanding of how to solve them. I know that this kind of frustration can be very difficult to deal with. It doesn't actually get any easier the better you get at programming. You just expect it to do more with your frustration. Everything's about trying to find the best ways to break problems down into smaller parts that you can manage, until your coding skills can definitely deal with it. But I leave you with this GIF anyway because I find it hilarious. It's just all of the tiny fails in life. I think, yeah, Tom's explaining a few things there. Okay, I'm gonna go on break now. This time I'm gonna leave you with this GIF. I'll just take my camera away and mute myself for a little bit. I'll be back very soon, and we're going to talk about two-dimensional arrays and then make some code. one of the funny things about this GIF is it really dates itself in a very particular era because it's got that DVD logo that bounces around the screen, and I have a feeling that not many people will necessarily have seen that because that's like super old school. The DVD players used to have that. Um, I think there was another one there as well. Like, oh yeah, the old Windows 95 loading thing that we don't really use. Like the progress bar doesn't quite look like that anymore. So it dates itself in a particular era, but I think it's still quite funny anyway. We have all seen the DVD thing. Okay, fine. All right. Okay. Okay. I consider myself served. I've been I have misjudged my audience. Okay, let's go back to some of the slides that I was going to talk about. I got a bit distracted by talking about the scanf stuff, but the scanf stuff's kind of useful anyway, and it's learning about what some of the subtleties of functions are. So, where am I? Here. Damn it! I'm giving away my meme there because I think people would have seen that as we go through. Okay, so arrays. Arrays being collections of variables of the same type that we're going to use by declaring the bunch of them together. And each particular variable in here it's nearly not even a variable. It's just a memory location. That's kind of what a variable is. But anyway, we access them by indexes rather than the names, but we would use the name of the array to do it. A bit of a quick recap on the code. We would declare an array using the square brackets. So the square brackets is the symbol of the array. It's going to be used in two different ways. It's going to be used one way when we're creating it, and it's going to be used a different way when we're accessing it. So if I'm going to have an array of doubles here that starts off as all zeros, maybe I should put a 0.0 there, but I think the double array is going to deal with that either way. I'll call it my array here and say there are 4 elements in it. So the first time we create an array, the square brackets is used to say how big the array is. From then on, anytime I use that array by saying this array and the square brackets then say I'm going to access one element of the array. So this says I'm going to take the second element in the array. So the number in there is the number of elements you're going to skip over before you get to the one that you're going to change. And I'm going to set the second element to 0.95. And I can use that as if it is a variable of the type that's stored in the array. So this, I mean, it's not perfect. I'm comparing a double to an integer here. You want to be a little bit careful about doing stuff like that. But at least I can say if the third element of the array is less than 1, then print out the third element of the array here. So these are just some examples of how we can access it. If I want to access multiple variables, I can loop through the array, and I think we've seen this a little bit now. As you get into your tutorials this week and labs, you're going to be doing more of this practice to get an idea of how arrays work. We're learning a little bit about arrays and functions at the same time, so I'm going to start using functions that work on arrays. We tend to do that a lot, where a lot of the time if we're going to do stuff with the array, we're going to bundle it into a function. So I'm trying to get it so that you can learn about both of these things at the same time. I'm just getting slayed in chat, I think, by people who are like saying that I don't I don't I'm not picking my audience. I'm gonna have to check all of my memes again to make sure that they're still current. Or I can go back to the very first meme I said, where it's like, what's his name? It's not Willem Dafoe. It's the other guy with the no, it's Buscemi, Steve Buscemi with the skateboard. It's like, hello, fellow kids. Every now and then I'm going to get caught out trying to relate to you, and then you're going to remember that I'm like twice everyone's age, and I don't really exactly perfectly relate. Okay. This is something that I haven't spoken about at great depth, but it's important to think that when a program runs, when a program first starts, all of its arrays have to be kind of not necessarily reserved the amount of space they have, but they're fixed and they can't actually change their size. So this is something, the subtlety that I think is going to be very different from people who have learned other languages. Like if you've done any C# with vectors and stuff like that, you can just say, this is a thing that contains numbers, just make it the right size, and it will grow and shrink depending on what you need. Arrays don't do that. Arrays are a fixed size, and they're going to be exactly that size for the whole time the program runs, and they can't change. So, this bit of code cannot work. I can't have a variable with a value that I'm not sure of. Even though this, in code, it's not going to change, the fact that it's a variable means that it can change. I can't use a variable to decide how big my array is. So I can't say that I could have an array of different sizes, and I'm not going to know until, like, say I take user input on how big an array is going to be. So this will not work. This will cause an error and say, no, you can't declare an array with a size like that. It has to be a fixed size. The only way we're going to be able to get around this is using a constant for the array size, where I could do a hash define. I probably wouldn't call it array size. I would give it a value. I would give it a name that matched the type of elements that I'm storing. So, for example, I did this last week with the number of players in the game. I think I did, didn't I? Yeah, number of players in the game, and it was like 4 players, but you could potentially change it to a different number of players. This will work, and this will give us the ability to change the number of elements in this particular array, but only each time we compile the program. When we run the program, we can't have a variable saying how big the array is going to be. So just be careful with that. Arrays are a chunk of memory. In order to get that chunk of memory, you've got to grab it when the program starts, which means you need to know how big it is when the program starts. So the define will have a value that is always the same when the program starts, so that's okay. But a variable is something that can change as the program's running, and so we don't allow this when we're creating an array. Okay, so here's the meme. An array is a type of variable. Hang on a second. I thought that might be happening. I'll put my face down here somewhere. An array is a type of variable. You can put any variable inside an array. This means you can put an array inside an array. So what we're getting now is the idea that if I put an array inside another array, then I've added a dimension to these arrays. So if I put an array inside an array, then instead of having a line of variables, I've created a grid of variables. If I decide to contain an array of arrays inside an array, so I make multiple arrays of those, I could make a 3-dimensional grid of integers or doubles or some kind of variable. I can go further than that. I can go well beyond what humans are okay with dealing with, and I can put a 4-dimensional array of integers together, or a 5-dimensional array of integers. Personally, I don't like 4-dimensional arrays because they break my brain and they stop it from working properly, but it is possible. Like all other things in C, we can write C, which does a complete bamboozle and means that people can't understand what's going on. We're going to go as far as a 2-dimensional grid, and we're not even going to look at the 3-dimensional, even though humans can understand 3 dimensions reasonably well. I mean, we live in 3 dimensions, so I hope we can understand it. We're better at 2 dimensions than we are at 3. So we're going to push it to 2 dimensions so that you know that the idea exists that we can put arrays inside arrays, but we're not going to go any further than that. Let me put my face back up there. So, this is what a 2-dimensional array might look like. It is not exactly a grid in memory. So it's not that in memory we'll get a square chunk of memory. This is actually going to be all in a row, but we can think of it like that because we can use it like a grid. So I have the indexes for sets of arrays. So there's one array that contains arrays, and in each of the arrays in that array, it can contain these numbers. So this is a two-dimensional array of integers. You could consider that one of the arrays is this one going down the side here. So the first element of this array is an array. The second element is also an array, and the third element is an array. In each of those arrays, the first element of this one, for example, is a number, second's a number, third's a number. So what you get is there's an outer array that contains arrays, and the inner arrays inside those contain integers. And then it's reasonably possible to understand this at that point. Because once we get down to it, it turns into a grid system where we're going to use coordinates, which are our indexes, to access individual elements in the grid. So individual squares in the grid. When we're doing this in code, we do this reasonably simply by just declaring the 2D array with a second set of square brackets. So we can do this without having to create every individual array that's going inside this grid. We can just say this is a 4x4 grid of integers, and we will get 16 integers organized in such a way where there's 4 arrays, and each array inside has 4 of them. These don't have to be the same number. As you can see here, I can have different lengths here, so they don't have to be squares. I think in the assignment we're using a square grid anyway, just to make it reasonably simple for you. I think it's a 15x15 if I remember correctly. So this gives me a whole bunch of integers that are organized in such a way that to grab a single value, I will give it a pair of indexes. So I will say grid 1, 3 says I'm going to go to the second set of arrays, and then the fourth element in the second set of arrays. So if it was this one, it'd be the second set of arrays. I think it was 1, 3, wasn't it? So 1 here, 3, and they would access this individual element, 21. So one thing I can suggest if you're working with two-dimensional arrays is draw a picture. It's going to make it easier for yourself. You can draw a picture with the indexes along the top and the side, and you go, okay, how am I finding each element? That kind of thing. So same as other things that we were doing, once we have accessed an individual element of the array, it's just an integer, right? So this is an integer array. Once I've accessed a single element, then I can treat it just like a normal integer. So I can assign it a value, I can check its value against other things, that kind of thing. If I was to leave off one of these sets of square brackets, then grid 1 would be saying I'm looking at an array of integers then. So it's nearly like grid 1 is an array of integers, and then I put square brackets on that saying, okay, I'm looking for one of the elements in that array. So this adds one layer of complexity, but it doesn't add anything that you don't already know if you know how to use one-dimensional arrays. Okay, that was our break. Now I'm going to... Jasmine is saying, so this is what we'd use to say print a board game board. Yeah, you totally could. If it's a square grid board game, you could definitely do that. Riley is explaining a four-dimensional array. I'm not going to go into the four-dimensional array. I remember learning this when I was learning how to do certain mathematical forms of animation, and it was like, all you need to do is map a three-dimensional sphere. No, map a four-dimensional sphere into three-dimensional space, and I was just like, I was like, okay, I'm going to pretend I understood that. And like when my lecturer at the time got to like, yeah, and then because we can see a four-dimensional space, then we can map the five-dimensional space to the four-dimensional space, and that gives us this capability. And I was like, what? We're not going to go into that. Yes, at the moment in the assignment, Tom's answering questions there about is it rows then columns or is it columns then rows? It doesn't particularly matter, but as long as you always agree that it's one way, then you can use it. Then you can visualize it the same way. Don't flick back and forth in a single project because you will break your own mind. Okay, so I'm going to do an example now working with 2D arrays. And this is a really, really simple game that I call the Tourist. And it's the idea that what we're going to do is control a little tourist that can move around in a square grid. What I want to do is to be able to print out the world. So I want to be able to print out the 2D array. You may already have guessed how we're going to print out a 2D array because we've been doing a lot of printing of square grids without arrays up until this point. We've been printing out things like a hollow triangle or an X of asterisks and stuff, or if you got deep into it, a spiral and things like that. But we're going to be able to print out a square grid, and now we're going to add the arrays to that. So previously we were just working with double loops. Now we can see how the double loop is going to work with the double array. Now that we have, see, it was slowly building up all the different capabilities, so now we can do this with the double array. The tourist is someone who wants to see the world, but they don't want to go back where they've been. So we want to track, using this 2D array, this map, where the person has been as they move around. And if they go back over places they've been before, they lose the game, lose this little game. I'm not sure if we're going to get through all of the content for this, so some of it I may leave for you to complete later if you want. But at least we're going to start working with these 2D arrays. So I've got some starter code. Starter code is available in the lecture section. So I'm going to go through this and show you what the starter code is. The starter code is actually reasonably similar to the starting code in the assignment. And so that's why I wanted to show you sometimes, like, sometimes we'll have some code to start with and we'll use it. And we'll work at kind of building up from what we can see in it. So there's a function we're already going to be using called print map that's in the starter code. I think, if I remember correctly, there is the same kind of starter code in assignment 1. Anyway, let's hop across to VLab. Get my scanf demo because I'm not going to use that anymore. And I'm going to look at tourist here. Oops. That is paint.c is, I think, 2 or 3 iterations ago for the assignment. So let me just say the starter code. We do very different assignments, but we still try to get you to do the same work in all the different themes that we have for the assignment. So this is not going to be that different. Okay, so we have our standard input output.h. We have for a moment here the dimensions of the map, the number of rows and the number of columns. I think that in the current assignment we don't have a different size, we don't have different aspect ratios of rows and columns. I think they're all square. So in the assignment this might just be size. Then we have this function called print map. This is going to print out the map as a 2D grid. We've got our main function here that has nothing in it yet. So this program's not going to do anything for the moment, but it's got some backup information for us. So here is our printing the map. This, if given a map that is of the correct size of those hash defines, it will be able to print out this map, and it takes in a position row and a position column, and it prints a T instead of the integer value stored in the map if it sees this position. So you can see we've got 2 loops, and I've been quite specific with how I do this looping to remember that I have rows and columns, because when I'm printing to the screen knows rows and columns. It's going to expect things, and it's much easier for us to print rows, complete rows, and then print columns, other than because you can't really print vertically and then go back up a line in the terminal, which is why this is rows first then columns. It makes it much easier for us to print. So for each row we print all of the columns in a row. If the position happens to be the one that that we have stated here. It prints a T, that's the tourist. I'm putting a space in between everything so it's easier to read. If it doesn't print the tourist, it then prints the number in the map. And so we're going to use the number in the map to just track how many times the tourist has been there before. Yeah, Tom's just clarifying the rows versus columns things. SK is saying that if you had a while loop in a while loop in a while loop, you could print 3D patterns. Yes, I mean, so long as you have something that can deal with 3D, you could, if you want to, have a sort of a 3D block, and then you could draw patterns inside that 3D space, and then be able to, like, kind of, if you had the maths to do it, you could rotate it around and look at it and stuff like that. You are potentially going to get to that point if you want to do things like 3D graphics and stuff like that, which CSC does have a course for that. It may be happening in the future. I know it's not running this year. Anyway, so this is our thing that can print out the 2D grid, and it will either give a number or a T wherever the tourist is. So what are we going to do if we have this much so far? Let's break our problem down into small achievable pieces. So the first thing we want to do is say, let's make the grid. So let's actually have this two-dimensional array, and let's track what the tourist's position is in this array. And tracking the tourist's position should be reasonably easy. We're not going to actually write the tourist's position into the map itself, but we're just going to track the tourist's position separately, because we know that the tourist only has one position, so it's going to have integers for the row and column that it's in at that particular time. There's actually a player in the assignment that goes across the bottom of the screen, so chances are that's probably going to be an integer as well. I'm not sure if we've specifically said it has to be or not, but that would be an easy way to track it, as like which index of the column is it currently aimed at. Then as the tourist moves around, we're going to need to set the locations it's seen to 1, but we also need to figure out how it moves. So let's not get to any of that yet. Let's just set up the grid and the tourist position, and then look at some movement code before we get too deep into things. Okay, so simple things first. I can set up the map and then the position of the tourist. So I can have those variables here in my main. So first thing, two-dimensional array for the map. That's going to be 0 because I want the entire map to start empty as zeros. And so if I'm going to keep this format of rows then columns, I'm going to have n rows and n cols. I'm definitely going to use my hash defines here. I'm not going to put any numbers like 10 in here, because if I put numbers in here and then I go up here and I say, okay, I want to change the size of the map, I'm going to cause problems if I haven't used my hash defines properly. So I want to use my constants in here. Then I'm going to start my tourist at a particular position. What was I calling it here? Position R and position C. That makes sense. So I could use X and Y for this, but I'm going to use R and C for rows and columns, because that is going to keep it really, really clear in my memory which things I'm referencing, whether they're rows or columns. Once we start putting X's and Y's in, we have the potential, depending on your brains themselves, we have the potential of confusing ourselves, because we forget that which one's Y and which one's X, and then we start to slip into the mathematical way of doing things, where the X usually goes before the Y, and there's conventions there we might break with ourselves, which is why I'm going to avoid using X and Y and use rows and columns instead. Because for the purposes of being able to print this thing out, and the way that we think about things with arrays, it's easier for us to think of rows first than columns. So we've got the position in the row and the position in the column. I can declare, actually, you know what? I'm not even going to declare the multiple integers in one line. I can declare them in one line, as we see here. But sometimes it's nice to have it vertically because it reminds me exactly how many variables I've created. I can actually test if this is working right now because I've got this wonderful print map here. I can go, did I print this correctly? Print map. So print map takes in a two-dimensional array called map. Oh, actually, it doesn't matter what it's called. I'm going to give it this one, and it's going to rename it map inside its own function. So that's fine, because they happen to have the same name, which is alright. Oh, all these variables have the same names here. They don't have to be the same, by the way, as we've shown before. The only thing that's important in this declaration of the function here is the types, and the types must match. So, note, I'm using an array without using any square brackets. If I don't use any square brackets, then what I'm giving the function is the entire array. If I was to put square brackets here, I would be saying I want a single element of this array, or even deeper, a single integer inside this array. But if I want to give it the whole array, oh, hello friend. Chicken's just come to say hello again. Hello. Just looking for somewhere warm to sit. What I'm going to do is give the function exactly the inputs that it wants. So it's saying, give me an array, give me the position in the row and the position of column of the tourist. So position row, and then position column. I've made sure that these are the right types. One is a two-dimensional array, and that matches. And then two normal integers, they match the types there. They happen to be exactly the same name, but they don't have to be. Okay, so let's just save this and then compile it. Oops. Oh! I love this because I wrote this, like, when did I write this? June 2019. I left an Easter egg in here, and it's managed to survive all the way along here with me even forgetting what's going on. Look at that. Anyone see what I did there? I realized that at this point I started ramping it up and I started dropping things in there to see if people were watching or not. Oh, you want Chicken to perform for the camera, do you? Anyway, so, can anyone see what I'm doing here? I have got a single equals instead of a double equals inside my if statement. What this is going to do is it's going to end up with assigning the current column in this loop to the variable position C, which would overwrite the variable of position C and cause some problems. DCC is nice enough to tell me that there's an issue there and saying, I cannot assign that. There's an issue with what I'm doing here, so we should have a double equals there. A little bit of an Easter egg. I'm going to leave that in there for future students as well. Okay, compile that again. Alright, so nice to know at least that this is compiling. Let's run it and see what it shows me. So hopefully this is just going to make a call to print map, showing us what our map looks like, and there'll be a location 0, 0 where our tourist is. Okay, so it's all zeros, and the position 0, 0 is the first row and the first column, so that's the top left. Bear in mind that when we're doing this, because we're going to be writing things in rows, that our 0 is going to be our top, instead of the way that we would do this in maths, where our 0, 0 would be in the center of a grid, or if we were only using positive indexes like we are, it would be the bottom left corner. Computing tends to put the 0, 0 in the top left corner rather than the bottom left corner. This is actually left over from the old days, where the most common and nearly the only, like if you go back far enough in time, the only two-dimensional grid that we were ever using was our screen. And so there would be what character is in which position on the screen. And the way that the screens used to be drawn back in those days, if anyone's used a CRT monitor, so now that I'm not sure about where to date my audience anymore, I don't know whether I need to explain things or not, But the old CRT monitors are the ones with the big chunky thing on the back, so they're not a flat LCD panel. They're a whole giant glass tube thing, and the way that they work, it's one of the nuttiest ways to actually get an image to display on a glass screen at the front. Is they fire a beam. It's not actually a laser, but it's just this beam of energy. And what it would do is it would be able to light up one pixel on your screen at a time. And they use magnets to move this thing around. And so it would go across the top of your screen. I hope I'm doing this the right way for you. Oh wow, I've nearly got it perfectly in the camera there. Okay, so it would go across the top of the screen. Then it would go down one line of pixels and it would draw the next one. Then it would go down another line of pixels and draw the next one. And it would do it row by row by row by row. Exactly the same way that this is printing out. So it's printing out a row and then it's going down to the next one and printing out a row. And so it always started at 0, 0 in the top left corner and it counted across and then down and across, down and across. And so we're replicating that. We're going to end up using the same kind of indexing for a grid like that. Okay, I am now getting old enough that I'm sure. Yeah. So I mean, like there was this wonderful kind of point where LCD panels appeared, and suddenly we didn't need these massively deep desks we used to use all the time for everything. But it also meant we dropped down to 60 frames per second, which I think for a whole lot of us who were gamers at the time and we're used to running everything at 100 frames per second, that was a disappointment, and it took nearly, I don't know, 15 years before you got back up to being able to do 100 frames a second. Anyway, so that's why we're doing rows versus columns like this, and why these things tend to do a row and then they skip to the next row and do it. So what we're doing is we're kind of sitting into the way that computers like to do things rather than necessarily forcing the computer to do it the way that the human likes to do it. There's always going to be a bit of back and forth between us and the machine. Okay, so our map is set up and our player, our tourist's position is set up. Next thing we're going to do is add movement to the tourist. So we haven't necessarily got something nice like 1511 arcade. We've got real-time control with arrow keys and stuff like that. But if we want to use what we know so far, we can at least take integers as input and we can use integers for directions. So I've got some code here that will loop, and it will allow us to every turn move our tourist around, and I'm going to use my numpad for this. So if you have a numpad on the keyboards that you're looking at right now, you can see that plenty of numpads even have arrows on the numbers 2, 4, 6, and 8. So 8 is up from your perspective, 4 is right, 6 is left, and 2 is down. Did I do that correctly? I always get flipped with the camera and I'm not sure if I'm doing it correctly. So what we're going to do is we're going to change the tourist's position depending on what input we get. I'm going to put more comments in than we've got in this actual code here. So what I might do for this is... Oh, actually, no, I can't do that in a function for the moment. But what I'm going to do is put some code in here that's going to take some scanfs. So it's going to take an input number, scanf, and each time it does this, it's going to show us where we are in the map. So I'm just going to set this to 0 in case I don't get any input, and then I'm going to scanf a integer into my input variable. Okay, so that's just taking some information from the user. I need to actually tell the user what I want. Please enter a direction using the numpad. Yeah, I'll put the colon in the space so that they can type directly after that. Okay, and that does the scanf. And then once we've got the input, then we're going to check whether the input is any of the things that we want it to be. So if, and what I might do is I'm going to set up my structure before I put all my code in it. And I'm going to do a bit of that thing that I was talking about writing the comments before the code. Up, down, I'm going to copy paste this. Up, down, left, and right. I might also put one final case in here. I'm just copy pasting this, saying exit. So if anyone's interested in programming games, every game's got one of these in it somewhere. Whether it's hooked up to someone else's code that's already done this, or you write it yourself, because inputs are so specific, and the the whole idea of key bindings to things happens, there's usually this giant thing saying, on every frame, if we're doing 60 frames a second, check for input. Which means check all the keys that have been pressed and see which ones are being pressed, and depending on which ones are being pressed, control the game in some way or another. So if I'm saying if something is up, I'm saying if input is 8, then that's up. If input is 2, that's down. If input is 4, that's left. If input is 6, that's right. And I'm going to say that we can exit the game by typing in an input of 0, which also means that if scanf fails, if someone types in something that's incorrect, we're just going to can the game. That's okay for the moment. Maybe we would want to make it nicer than that if we were checking for invalid inputs. But for the moment, we're worried about working with the array rather than dealing with invalid input with the time that we have left today. Tom is answering a question there. I'm gonna leave that because Tom said that's a long and complicated question, so I'm not even gonna get into that with the time I have left. Okay, so up, we need to change the variables for our tourist depending on the direction we're going in. So if we're going up, as we said here, 0, 0 is the top left corner, which means that if I want to go downwards, my row number is going to increase. If I'm going to go upwards, my row number is going to decrease. So my position in the row minus minus will go down 1, which means I will go upwards. Down will be the opposite of up. So my position in the row will increase if I'm going downwards. If I'm going to the left, so leftmost, top left is 0, 0. As I go to the right, it increases. If I go to left, it decreases. So I'm going to say my position in the columns is going to decrease if I'm going left. And my position in the column is going to increase if I go right. The exit I will deal with once I have put this in a loop. So I'm going to have a loop that potentially goes forever, because I want the person to be able to just walk around as much as they want to. So let's put some of this stuff in a loop. So I've got, that's where the loop opens. And I'm going to close the loop here because what I want is to see where I go every time I move. Going to select all of this and press tab. And so now I'm nicely indented because I've just put this stuff inside a while loop. I don't want a while loop without a condition, so I want to make sure that there is a condition here. So I'm going to make a sentinel value. We've done this kind of loop before, which says that I'm going to end under certain conditions. So I'm going to call this exit loop equals 0. And so I'm going to say I'm going to exit the loop once this thing becomes 1, which means I'll show you using some of the stuff that we have with our logical operators, this is a way that I can say flip this from a true to a false. So if I am not exiting the loop, so we can use not to explain the exclamation mark, this is going to flip this 0 to a 1. So this is going to run anytime I am not saying exit loop, and once I say exit loop, the while loop will stop running. So I can say that if I got the exit, I was going to set exit loop to 1. Okay. This is the main game loop. Take input and print the map each time. Okay, so now I should be able to move around on this map by giving my numpad input, and that will change the position in the rows and the columns that the tourist is in, and then print out the map. So let's see if this is working. Wait, let's see if I saved that first. Control S to save, just in case. Up and down arrows to get my DCC command. And then I will run tourist. Okay. Oh, maybe I wanted to print this out before I asked for a direction. If I don't know where I am to begin with, I would need that. Anyway, I'm going to use my numpad. Oh, my numpad. Hang on. I'm going to turn on numlock. Make this easier on myself. Okay, 2. Enter. So I've come downwards there. I'm pointing at my screen. I've gone down 1 there. So let's go to the right. There's a 6. Go to the right. Another 6. And you can see here, I'm just typing in my numpad directions. I now have the ability to move around in this scene. Oops, I pressed enter too many times. Yeah, so it's nearly like, because this is printing out again and again and again, exactly the same format, it's nearly like I can watch this thing moving. Cool. So I can walk around, and let me just keep walking around. Oh no! Oh no, where did he go? Where did he go? What's happening? He's walked off the scene. Oh, let's see if I can come back. Okay, there we go. So this is not complete. We have some potential issues. Ooh. I wonder what it's going to do with 68. Oh, it just left me where I was. Good. The downside of what I'm doing here is I've set up a system where I can move, but I've also set up a system where I can leave the map entirely. I can walk off the edge of it. So I may have to do something with that. Someone was asking about the exit loop equals 0. And someone else was talking about the numlock. Yeah. Okay, so let me just exit this with the 0. Okay, so I know that all the control code that I put in there is working. I'm going to put quotes around working, because me being able to walk off the map might mean that that's not working. We'll maybe look at that. In fact, I probably won't look at that, so I'm going to leave that as a challenge for you, even though it's in the slides, to see what you're going to do about if I can walk off the map. And I'm going to start doing other things with what's going on. And what we're going to do now is we're going to track where we've been on the map. So what we're going to do is everywhere we are, we're going to start marking the places we've been so we can see where we've been on the map before. What I might also do is instead of printing map, actually no, I'm going to print the map once before we start so that we can see it, and then we're going to print the map each time after we move. But what we're going to do is we're going to say everywhere we've been, we want to track how many times we've been there before. So even before we start asking for input and moving, what we're going to do is we're going to basically draw on the map where we've been. So we start at a particular location, and so what I want to do is I want to say, let's make a change to the map itself at that location. So the map at our current position for row and our current position for column, this is an integer in the map. I'm going to add 1 to that to say I've been here already, and then I can move somewhere else, and then when the loop comes around again, I'm going to change the information for where I am. So now when I walk around, I'm going to leave a trail of numbers for where I've been. Yeah, I think Jet's already answering the question there about the exit loop. I don't need to test it for 0 because the exit loop is an integer that can be checked for the true false, and I'm just saying flip it to its opposite and then check it. Okay, so this is going to add 1 to any place that I've been already. Let's have another look at this. Now, if I compile it and run it, as I move around this time, I should see the trail behind me of where I'm going. So I start here, and I'm going to go down with my numpad, down again to the right. And so what's happening now is everywhere I go, I leave behind me a record on the map that I've been there before. I'm going to go back over where I was before, and you see now it's going up to 2 if I visited that place more than once, etc. Anyone ever play the Snake game? Now I'm dating myself. Anyone ever had a Nokia phone? This was the kind of thing we used to use to distract ourselves on public transport, etc. is to play the Snake game on our phone. Okay, so now we're getting to the point where we can see where we've been previously by just adding a number to the grid in those particular coordinates. Oh, let me show you what happens now if I walk off the edge. Ooh, it didn't break. Oh, there you go. So, Mason is asking how I clear and reprint the map in the terminal after every movement. I'm not even clearing the terminal. So if I scroll up, I'm not clearing the terminal, I'm just printing it again and again and again and again. It just looks nice because it happens to keep appearing at the bottom of the terminal. So every single step was a separate print, I wasn't clearing it. So there was just the appearance of animation, it wasn't genuine animation. Yeah, people are talking about Snake, yeah. And Jet's asking for our assignment, will it look like this every time we print the whole map? It'll be a bit similar to this. There's the assignment as it is in the spec is going to allow you to keep printing the map every time something happens. Yeah, okay. Motorola flip phones. Okay, so I have an issue here. What I have done now, and the weird thing was, so previously I could walk off the map, right? And that's interesting because I could walk off the map because what I was doing previously when I was walking off the map was I was just changing these numbers. The position row and the position column had no relationship with the size of the array initially. Like, we were hoping to keep it within the 10 by 10. And so I could walk around, but then I started drawing stuff onto the map. So I started writing onto the map, which is me saying, find this location in memory for the map and add 1 to the number that you find there. Which means now, if I walk off the map, it's much more dangerous because I'm walking out of the bounds of the 2D array. And so I'm accessing an element outside the bounds of the 2D array somewhere, and I'm trying to draw that information, that 1, to it. So if I add that number there, I'm trying to modify an array outside of its bounds. And now the idea of me walking outside using these, using the numpad directions is much more dangerous because I'm no longer just walking anywhere I want to. Now if I walk off the map and I try to draw on it, I'm causing issues. This is nearly like a Turing machine where you walk around and then you draw ones and zeros. It's in 2 dimensions, but like, you know, a Turing machine could do 2 dimensions by putting things next to each other. Yeah, so the walking off the map is now much more dangerous. Usually at this point I would want to try to fix that, but we've hit 11 a.m. and I don't really have time to fix that. What I might do, I'm not sure. Let me quickly gloss over what I would do for the rest of this now, because I still had things that I was supposed to do, like not just track where the tourist is on the map, but also check if we've been there before, and maybe exit the game if we've been there before. So what I could do now is every time I move to a new location on the map, I can check if I've been there before. So I can check if it's already 1 if I've been there before, or I can check if it's greater than 0 if I've been there before. But I mean, I don't know how it would get to 2 if it was going to exit the game anytime it got greater than 1. And what I can do is, if I wanted to exit then, I could, after my movement here, I could just do something like this. Where are we? I can check the map in my current position after I move, position row and position column, and if that's greater than 0, we've been here before. I can set the exit loop to 1, saying we're going to exit, and I can printf to the user I've seen this before. How boring. The tourist is very specific about what it wants to see. Right? So, actually, let's run this at least, so I'll show you how this works. I'm going to compile that and run it. Start walking around. I'm going to loop back on myself just like in Snake, and I'm going to hit a point where it's like, oh, I've seen this before, how boring. It does still print out to us our final location here, but it does exit there. So that's a nice way to kind of finish it off, where you go, okay, at that point, that's where the game ends, because the tourist doesn't like seeing places that it's been before. Some other things that we could do with this is, instead of 1s and 0s, we could have a hash define for unexplored space and explored space. This would make our code much more readable, so it'll be really easy for us to see what's going on. We've got these English words in there that explain to us what's happening. And that's our game, reasonably complete as it is. So we can move around, we can track where we've been, we can display where we are, and if we go back somewhere we've been before, then we've got an issue. However, we do have these other issues where if we move off the map, we've got problems. If we have different inputs, maybe we've got some other problems. I won't go into that now because we're out of time, but there is some code here in the slides that you can continue with if you want to make sure that we don't go off the edges of the map and things like that. Anyway, I'm going to wrap it up here. QWERTY11 says, looks a bit like Minesweeper. I don't know, you probably have heard this maybe already. We've used Minesweeper as the theme for one of the assignments in this kind of thing. Okay, let me just take a quick break, and then I'll come back and answer any questions. But for the moment, that's the official lecture over at this point, but I'll come back and answer people's questions if people have any, and we can go back into like a deeper look at the tourist if you want to look at any individual parts of it, and ask me about how the code worked, you know. But I'll be back in a moment. Hello, I'm back. Oh, Charles, you have heard of that one. Um, let me talk about what Charles is saying because this is a really funny example. Um, there was a someone who made a snake game, and it's just a really simple snake game where um, a something like this tourist that's in a particular position on the map would decide randomly between the four directions it would go in based on whether there were zeros or ones there. So if there were zeros, it would move into the zeros and turn them into ones. And so it would just kind of walk randomly around this space, trying to avoid running into either walls or where it had been before. So it would just eventually kind of fill up most of the space or run into itself when it ran out of options. Um, this is old Linux programming, or may have even been Unix, but it was back when memory management was just sort of the responsibility of the programs in memory. So rather than it being you have your own little chunk of memory and you're not allowed to go off into other memory, this program could go off into memory that was outside of what was allocated for the program. So this is like the Wild West of programming days where we hadn't actually protected things properly. And so this thing would go into anywhere it found zeros and flick them to ones. And so it was okay if you'd set up your space with a whole bunch of ones around the outside and it couldn't get out of it. But what he did at some point, I can't remember the name of the program. I should look this up because I've used it as an example multiple times. It took some of the walls away, and the snake walked out of the program and it walked into memory. So it just started wandering through memory, turning zeros into ones. And the inevitable happened, which is like, okay, the entire operating system crashes, the computer turns off. You gotta turn it back up on again and hope. But there were some really funny things that happened. Like one of the runs, he just let it run and it went off into memory, and then the CD drive opened. So it was just like somehow, without crashing the operating system, this snake had made it all the way into the the code that says whether the CD drive should open or not, and it had flicked that one switch that said the CD drive should open now, and then it popped it open. And so, like, little things like that, it was just like really funny things about how you can just sort of dance into other memory by accident. Um, Also, I think I've mentioned that this is an old way of hacking, where you would be able to find your way into memory that you're not supposed to be in um, with your program, and then rewrite the code in other parts of your computer, and then get it to run, and use that exploit to take control of someone else's computer and things like that. Someone was saying that they were told about that last term. Yeah. If you've been watching any of my lectures previously, it's an example I love because it's so much fun. So we could actually make this tourist so that it wanders off into memory. The only issue is nowadays with our modern compilers, it would just go, nope, array out of bounds, you stop now, like this. We'll just go up. And it's like, no, you can't be there. Here is your index out of bounds. But it would be funny if we had an unprotected memory space where we could just wander around like that. Yeah. Okay, so Mason is asking a question. Also, now that we're in this open time afterwards, if you have any questions, please type them in now, and I'll answer them as best as I can. Although I think we've had the benefit of having Tom in the chat this morning, so I think he's been answering most of the questions already. Okay, Mason is asking, is there a simplest way to make it so we don't have to hit enter for movement, and instead we can just press the number and it will register as the movement command? There isn't a simple way to do this, unfortunately. There are definitely ways to set up the command line so that it works with that kind of interface, and then you could do this like kind of like a real-time game and have it as a loop. Oh, actually, I'm trying to think if there is a nice way of doing this. Not with scanf. but we would want to use a different function. So the way that scanf works is it allows the user to buffer input. As in, I could type a whole lot of letters, but scanf won't read them until I press enter. I'm pretty sure there are other ways of doing it that that won't do that. Actually, once we get into I'm trying to think about how we would do it. I know because I've made games in the console before, but I can't remember exactly how. And I know I was using C++ at the time, so it was a bit different. But there's definitely ways to do it. I don't think they're that simple. You could look them up actually. How to make the Linux command line program real time as such. Because I think the downside of us using scanf here is that we're never going to get a way of doing that, because scanf buffers input in such a way of, so here, for example, the 6 is not going to do any. Oh, actually, let me show you. I wonder if this will work. I'll do multiple 6s like this. What it's going to do is it's just going to store all of these, but the program doesn't see any of them until I press enter. It's losing my enter here because it's usually I'd have pressed enter between each of them. But if we consider this line to be the top line of this map, what it's then done is it's just taken my 6 6s here and it's moved me across 6 times. So scanf doesn't get to run each time. It will run and it will grab something out of the buffer every time something's there. So every time I typed a number, that didn't necessarily trigger anything, but when I press enter, then all of that stuff goes into the buffer. Scanf then has looped multiple times to grab it. Oh, I remember what we did last time. We had ways of telling whether keys were up or down, and then we'd have a loop that would just keep running. And so it would be constantly running, and instead of doing scanf for input here, this thing would be testing which keys are currently being pressed or not. And every frame that a key was being pressed, something would happen. So it's really like flipping the whole kind of architecture of a program on its head, where instead of saying wait for input and then deal with the input, what we would do is say 60 times a second, look at the status of the keyboard. If any keys are being pressed, then react to those keys being pressed. So it's a different kind of architecture. It's very much the way that we build games rather than the way that we build programs. Programs are like, okay, you do the thing as fast as you can, then you wait for the user. As opposed to games, it's just like you keep running at a constant speed, and every time you're checking your system for stuff happening, you see if the users ask you to do anything. So a little bit more subtle. But you can probably look that up and see. Okay, so Liang Chow's asking, can I see the roll call code? I'm not sure which one you're looking for, but maybe it's the print map. Michael, it's almost as if Mark Shi used to teach making video games. Yes, I spent a big chunk of my career teaching people how to make games. Okay, so the rows and columns, I think this is what you're asking about, Liang. Is the we're going to loop a two-dimensional loop here with the rows and the columns, and then when we're inside the inner loop, we have the position of the row and the column, and then we can see whether we're at the position the tourist is at for the T. Otherwise, we print out the value that we see in the row and the column. I think that's the bit that we can that I think that you were looking for, because there's not much else in here about the rows and the columns. Oh, Liang's asking if we can scan up the up and down arrow keys. Yes, we can. I didn't want to do that because I haven't taught you anything about them yet. There are certain things that will go as input to the I don't know if they actually get input as into scanf. I think because they're an invisible character, scanf might ignore them. But there are definitely ways to take the input for the arrow keys. They actually have ASCII values. I should not have said that. I'm going to talk about ASCII values later. But they have a code that gets sent to a program when they get pressed, and if you can extract that, you can use it. Yeah. Catherine's asking if the answers for the challenge questions from the tutes are available for prior weeks. I assume you mean the lab challenge questions. Yes, they are. I don't know if we've flicked over to available yet. Well, there's always like a delay period because anyone who has special consideration that allows them a week later to submit things can always submit a week later, and so we don't want to release results and like give them the answers beforehand because it kind of ruins it if you already know the answer. So the answers won't come out until I think a week after the deadline that is written in the lab. So you'll have the lab, first deadline is the week, second deadline is potential extension deadline. Answers won't come out until after that. So it's going to be like a week and a half roughly after your lab that the answers will come. And Catherine's saying, yeah, working through examples. So sometimes, I mean, some students are actually not going to need to do exercises without answers. Some students are quite happy to actually follow the answer and get a really good learning out of that. But other people are going to need the questions without the answers to learn. So we kind of have to do it that way and then give the answers later, and then everyone will learn. Michael's saying that week 2 is available via WebCMS, so I think week 2 should be available now that we're in week 4. Yes. Week 1 didn't really have difficult challenges at that point. There wasn't that much code we were doing. I think week 1 they were available nearly immediately because that one wasn't a fully marked one. But week 2, which has been marked, should also have its solutions available. Oh, Liang's asking you about the key up and key down, as in when the key is pressed and when the key is released. You can do that. There's definitely ways to do that in C. I think then we start getting to a level of real-time programming that we're definitely not going to be going into in COMP1511. I think we're going to have enough trouble working with the data structures behind what we're doing before we get into real time. However, that definitely works. I can't remember off the top of my head if there's a good framework out there that you can just use to make console games, command line games. Like make console games. Here's a PS4 game. I mean, there are things for that as well. Those are even bigger. Anyone heard of Unity or Unreal? Both of those things can be used to make console games. But if we're talking about Linux console games, it'll be different frameworks. Usually people working with like stuff like abandonware and stuff like that, they may have frameworks where even libraries for C that can do real-time input and output, things like that. Mason is asking, will this work for movement the tourist to the other side of the grid if the tourist walks off the map? So yeah, we could do a thing. Where... Oh, we're still here, aren't we? That was just still running in the background waiting for input. So we could do a thing where once we go here and I do a 6... Oops. The tourist could hop around to the other side if you want to. I think the solution that I was using in the lecture slides that I haven't actually implemented was if they try to walk off the map, they just can't leave and they just get stuck there. So we do the clamping thing that we did with the dice checker. Dice checker? Yeah, there's a dice checker app where it's like if you try to go outside the bounds, you get pushed back inside the bounds. And in terms of like having a certain amount of reality for a physical person walking around a space, that makes sense. They reach the end of it, so like, you know, they're on a 10 by 10 island and they try to walk off into the ocean. It goes, no, you got to stop there. You can't go any further. But if we're talking about it in terms of like a really abstract, like computer gamey kind of thing, if you walk off one side and appear on the other, you could totally do that. So you can think about the structure of how you would want to do that. The first thing you would do is like say, have I gone out of bounds? If I have gone out of bounds, where should I end up? You know? So you can already think about how you would solve that problem. So have I gone out of bounds is a really easy question to ask in an if statement. And then how should I react to going out of bounds is something that I can say, depending on where I am out of bounds, how am I going to react to this? So some ways are like just clamp the values and push them back in, which is going to push people back to where they were before. Or I can say if I'm out of bounds in this particular coordinate, so there's going to be 4 options. You're above, to the right, below, to the left. You can flip yourself to another location by changing the coordinates that you had. It's quite an interesting thing, and you can just keep going with these, right? So it's like, if I'm out of bounds, where do I go? And there's lots of different options. And this will teach you a bit about how to work with 2D grids and coordinates as well, if you want to try that. Oh, and Tom has a solution there where you could do something really, really simple, where position row is equal to position row mod 10, and then that way you'll always be within. If you walk off, then you'll get pushed back on. You'll have to deal with the negatives as well, but we have had a quick look at negative mods as well and how to deal with them. So you've actually got all the tools if you wanted to do the flip around to the other side code. We've actually covered it all in lectures. Alright, so yeah, Tom's got some cool ideas there. Oh, people are talking about ASCII and Unicode and stuff. Liang's still talking about other things about, I think, key presses. So you can use the key up to emulate pressing the enter key. Oh, right. I guess we could. Except the key up and the enter key are different signals that would be sent from the program to the program from the terminal. And so we'd be beholden to how the terminal's going to work. So if the terminal's going to be waiting to accept input, that input doesn't get to the program until the enter key has been pressed. So the key up might not actually do that. However, if you have a program that's set up specifically to check for key down and key up, then you could definitely do that. Let me just try this. Key release C. It's always hard to search for C. Oh, key press and key release interrupts in C. Is there a way to catch key press, key release events in a while loop in a simple C program running in a terminal window? Oh, there you go. Maybe. Oh, you cannot do this in a portable manner. Terminals such as xterm give you only the key that was pressed, not the release events. Graphical user interfaces often provide the ability to have separate events. Terminal emulators might. Getchar might do it. Ncursors as well. I think Tom was mentioning ncursors there. Oh, okay. So it's sort of potentially possible, but not amazingly easy. Oh, wow. It can be done. Yes, it's just super fiddly, and I would not 100% suggest it at this point. I think we're getting to the point where we're stretching what we're trying to do with the code that we have so far to be able to do that. So I wouldn't necessarily suggest trying to do that for the moment, because I think it's beyond what the capabilities of what we're doing with the code is at this point. Oh, right. Yes, so the problem for Catherine was you can't see the solutions if you're not logged in. Yeah. So we make all the questions public, but we make the solutions private to the students who are here. Because I know that there are some people definitely who are potentially looking at doing the course in the future, and they look at it, and if we give them the solutions to the entire course, then there's a chance that they will end up not doing any of the questions and just like typing in the solutions that were there previously. And while that you might learn something from that, we kind of want everything to happen in the time it's supposed to happen. So, spoiler-free environment. It's hard to do a spoiler-free environment when you're showing the same TV show every term, because like as much as I would love to rewrite all of the labs and the tutorials every term, that's impossible. It would just be way too much work to do. Um, so yeah, so that's why the answers are locked behind your ZIDs. Not that there aren't a bunch of people putting it online anyway, which is super annoying, but there's not much I can do about that. Okay, UG Lee has a question about the calculator. Press Control D to end the loop. The result displays as enter instruction, blah blah blah. How does this happen and how to eliminate the value? What's Tom saying? No, no, no. Into the depths, you're in too deep. Oh, you're talking. I reckon that's a reply. That was Tom's reply to me going and looking at key releases and stuff in C. I'm imagining, because I don't think that's. Yeah, that's all right. I ran away from that as well. Um. Okay, CS calculator. I haven't looked that closely at. I reckon, UG, that is a question to take to your tutorial and your tutor to see about that. Because I reckon that's the kind of thing we want to actually have to have a look at the code and see. Yeah. Um, yeah, I'm not sure right now because I'm not actually super familiar with that question. Someone else wrote it. So I reckon take that to a tutor. There's also lots of help sessions at the moment. So UG, I would definitely suggest going to a help session and asking them about how CS Calculator is working and maybe get them to look at your code and see why certain things are happening. Um, Charles and Tom. That's pretty funny. Yeah, Tom pushing too deep into trying to make real-time things work in a console. I mean, I've done it before. I know that it's not too hard to build that framework. I had a friend who used to make games back in the old days, like the 1980s and stuff like that, and he would actually build entire games in the console while people like me are building games in 3D engines instead. So it's like, yeah, he knew all the tricks, but I don't know them off by heart. Yeah. Oh, Yuji, your tube was on Monday. Definitely go to a help session in that case. Or if you ask politely to other tutors, you could hop into another tutorial. So chances are in the labs there will be maybe some time at some point um, for you to talk to tutors about things, and you might actually be able to get some help in someone else's lab. Um, oh, and forums, not too bad. Also, you can ask on the forums if you've got questions about the challenge exercises. Oh, okay. So Liang Chao has a potential answer to that. Is that it's still probably passing the auto tests, but it's still outputting something. So it's kind of like if I here go back over where I was before, I've got this kind of exit statement here, but it's still printing out this. So I think CS Calculator may have that kind of thing where it prints out the enter a thingy, what was it? Enter an instruction or something like that every time, even on the last loop as it's leaving. Dean wrote that question, Dean Wonder, and Dean Wonder's actually one of the main forum answerers. So actually pinging him on the forum about it might be one of the best ways to get some feedback on this. Oh, sorry, you were asking something else, Tom. You were talking to Dean about 1511 Arcade. I think 1511 Arcade's not written in C though, right, Tom? I think he wrote that in Python. I'm not sure. Yeah. Oh, Charles is saying forums. Do you mean Stack Overflow? No, I meant the course forum. Because the course forum's got people related to the course specifically to answer questions for you. Okay. I think this looks like we're wrapping up here because we've got more tutors than students talking at the moment. So if anyone has any final questions, anything about 2D arrays, functions, libraries, anything like that that you'd like to ask, please fire off your question now before I wrap up. Stack Overflow is more fun. Nobody closes discourse questions for being off topic. I think Stack Overflow would love to close off-topic questions more if they could only have enough moderators to actually do it. We have a ratio of moderators to students in discourse that probably allows us to control things a little bit better than Stack Overflow. Although I'm not sure. I know that Stack Overflow tends to go way off course a lot. Alright, I'm getting thank yous rather than questions, but I'll just stay on for a couple more seconds. Oh, I should also say goodbye from someone. She's been there the whole time. So she's just like, after she walked around for a bit, she was like, this is a nice place to sit. And she's just chilling there. In winter, she always likes to be close because we're very warm. Myself and my partner who live here, and so Chicken always wants a bit of warmth. Okay, let's wrap it up there. I will see you all. Oh, someone was asking, the help session was 4 p.m. this afternoon. Let me make certain of that. We're in week 4. There is a 4 till 7 p.m. help session this evening. Yes, so 4 p.m. today is the next help session. Charles, that's a huge can of worms. I'm gonna wrap up rather than talking about Order 3. I also don't want to give it away too much. I mean, at some point I could talk about what's in Order 3, but let's leave that for a live stream where I haven't already been talking for 2 hours about other content. I am going to do a live stream on Friday, actually, which is mostly about the assignment, but it will also have some time to ask questions, and we might talk about how we could do something like Order 3 in the live stream if we have time. Okay, I will see you all soon. I'll see you on Thursday. Thursday we're going to continue delving a little bit more into how we use memory in C. So, but Charles, ask again on Friday. We might have time to talk about it in the live stream. The live stream's a bit dedicated to the assignment, but we could potentially talk about it there if we have time. Okay, see you later.